In this video, we're going to talk about hyperbolas. A hyperbola is a set of points such that the difference of the distances from any point on the hyperbola to two fixed points remain constant. And these fixed points we still call foci, the same foci we talked about when we had ellipses. But it's going to be d1 minus d2 remains constant. And so there's two types of hyperbolas, like there were two types of ellipses, a horizontal one and a vertical one. So let's label this. These are our co-vertices, our co-vertex. Let's zoom in. These are my foci or focus. It kind of looks like two parabolas put together. This right here is a vertex, and that's also a vertex. But we do have something new here. These dashed lines here, we call asymptotes. This is a center. So horizontal open left and right, and then vertical open up and down. The only difference here is this is the vertex, and this is the focus, and then this is a co-vertex. This is still the center. All right, the center, HK, is the midpoint of the foci. The asymptotes are the diagonal lines that guide the curves. We've talked about asymptotes before with exponential and logarithmic functions. The vertices are our turning points, are plus or minus a units away from the center, and the co-vertices are still plus or minus b units away from the center. The foci are still plus or minus c units away from the center. But to find the c this time, it's c squared equals a squared plus b squared. And so if we want to write this in standard form for horizontal one, we're going to have x minus h squared over a squared minus y minus k squared over b squared equals 1. And to find our equations of our asymptotes, if it's horizontal, y equals plus or minus b over a times x minus h plus k. And then if it's vertical, we're going to have our standard form is y minus k squared over a squared minus x minus h squared over b squared equals 1. And our equation of our asymptote is y equals plus or minus a over b times x minus h plus k. So when we're graphing hyperbolas, you're going to write the equation in standard form, and then graph the center, graph the vertices using your first denominator. In hyperbolas versus ellipses, your first denominator is always a, and then the second denominator is always b. And then we will find the foci using c squared equals a squared plus b squared. And then we're going to write equations and graph the asymptotes. So we're not going to do them all. We're just going to do some. We'll do number 1. So the center is HK, so 0, 0. A squared is always first in this case, so it's 4. So A is then 2. And B squared is 9, so B is 3. So our vertices will always deal with A. So we have 2, 0, and negative 2, 0. And then our co-vertices are 0, 3, and 0, negative 3, just by A and B. So if I wanted to graph this, I'm going to graph 0, 0, 2, 0, negative 2, 0, and then 0, 3, and 0, negative 3. And if I wanted, I could draw a little box so we know what we're dealing with. So since it is x comes first, it's going to be a horizontal one. So, and then I'm going to find c squared, or c, so c squared equals 4 plus 9, so that's 13. So c is the square root of 13, which is approximately 3.61. So my foci are 3.610 and negative 3.610. And then to find my asymptotes, since we know it's horizontal, we can go back and look at our asymptote equation, which is y equals plus or minus b over a x minus h plus k. So x and hk 0, 0, and it's y equals b over a, so 3 over 2, plus or minus x, so y equals plus 3 halves x and negative 3 halves x. So those are your asymptotes. So if I wanted to graph those on here, they'll go right through the corners of the box. That's why sometimes it's nice to draw the box. Nope, that one didn't decide to work too well for me. Well, you get the point. And then you just kind of use your vertices and sketch. Let's use red so you can see it. Sketch your hyperbola. And just understand that your foci will go there-ish. So that's your hyperbola. All right, let's go to number 3. So number 3 has a center at 3, 2. And it's also horizontal. So, well, let's do, since it's also horizontal, let's do number 4 because number 4 is vertical. So 4 has a center at negative 1, 3. So since I have, then a squared is 36, so then a is 6, b squared is 9, so then b is 3. So I have a point at negative 1, 3 is my center. And then it's vertical. So it's going to be, we're going to add 6 to 3. So I get negative 1, 9, and then I get negative 1, because I subtract 6, negative 3. So those are my vertices. And then my co-vertices, I'll have 3, stay the same. My y-coordinate will stay the same. And then add 3, so you get 2, and then subtract 3, you get negative 4. Those are my co-vertices. So if I wanted to graph those, those are my vertices, and then let's find my co-vertices. Let's make those blue. Then we'll draw a box, dotted box. There's my box. And so I know that my things are gonna look, my hyperbola is gonna look something like this. I just don't know really how steep or anything it's gonna be yet, given we don't know what the foci are. So something like that. I'll change it in a second. Let's find our foci. So c squared equals 36 plus 9. So I get 45, and the square root of 45 is approximately 6.71. So then I have foci that are -1, 9.71, and then -1, -3.71. And then to find my asymptotes, I'm going to take y equals, and then it's a over b. So 6 over 3 is plus or minus 2. And then x minus h, so x plus 1 plus 3. So then I need to distribute and simplify, so I get y equals 2, x plus 5, and then y equals -2x plus 1. So those would be my asymptotes. So if I graph those on here, something like that, and then graph your foci, and there is your hyperbola. For the next few, I'm not going to solve all of the information, but I am going to talk about how to get to that point. So, like ellipses, you need to get them equal to 1. So for this one, I'm just going to divide by 100, and then simplify. So I get y squared over 25 minus x squared over 4 equals 1. So then go from there and solve your center and your vertices and your foci and co-vertices and all that fun stuff and graph it. This one I'm going to have to complete the square. So I'm going to have x squared plus 10x plus something minus 9y squared equals -16 plus the same something. 10 divided by 2 is 5, squared is 25. So then this becomes x plus 5 squared minus 9y squared equals 9. I need to divide everything by 9. 1 equals -y squared over 1, and then x plus 5 squared over 9. And then for you to do this one, I also need to complete the square, but not with the 36, with the y's, because I don't have any other x's, so I have -36 x squared plus y squared minus 6y plus something equals -45 plus another something. -6 divided by 2 is -3 squared is 9. So -36 x squared, and then I need to factor y plus y minus 3, not plus 3. Minus 3 squared equals -36. Divide everything by -36. So those I get x squared over 1 minus y minus 3 squared over 36 equals 1. And then last but not least, I'm going to have to complete the square twice. So I have, let's just zoom in here. So -4x squared plus 40x plus y squared plus 12y equals 80. So then I can factor out a -4 for the x squareds, for the x's, so -4 x squared plus 10x plus something plus y squared plus 12y plus something equals 80 plus something and plus something. This is 25, so 25. But remember, I gotta do the 4 times 25 because I gotta multiply by -4 times 25. And then this is a 36 and a 36. So this becomes -4 times x plus 5 squared plus y plus 6 squared equals 16. So then I'm going to divide everything by 16. This is 1. That's easy. This becomes y plus 6 squared over 16, and this becomes -1 over 4 because I want it in standard form. So I switched the order because this guy here is negative. So, all right. Now the rest of that is for you to find the center, vertices, co-vertices, all that fun stuff.